In this lesson, we are looking at how to re-express data with the purpose to try to make a curved model more straight. Your textbook identifies some other reasons that we would re-express data, but in this example, we're going to look at specifically trying to be able to use a least square regression line. So a least square regression model really is only used for quantitative data that is linear. So let's look at this example. It says here is all the data of all iPhone sales during their opening weekends. I've taken this data and I've entered it into my calculator, and I'm supposed to make a scatter plot sketch. So I'm going to go into stat plot and go ahead and do that. Turn my plot on, select scatter plot, and my data is in L1, and I need to change this to L2. And if I hit zoom 9, I see my scatter plot, and at the beginning of this unit, we may have thought that this was a fairly decent scatter plot, but I think I'm seeing a bit of a curve here, and that's just a really quick sketch for note purposes. Okay, so the first question is, would you use a linear regression to model the data? Well, you know, at the beginning of this unit, you'd probably say, yeah, it's fairly linear, but we now know if we're a little bit unsure, we should run a residual, or look at a residual plot rather. So to do that on the graphing calculator, I go to stat calc and I actually run my regression model, and then it automatically stores the residuals in the background. So I'm just going to calculate, look at my coefficient of determination, 0.91. That's pretty high. But when I look at my residual plot, let's see what's going on here. So I change it, keep my x's in L1, and in L2, I go to my list, second stat, and on my calculator it's option 7. On yours, there's a good chance it's a different number. So I do zoom 9, and gosh, I'm looking at that and I'm thinking, wow, I'm really seeing a pattern right here. There's a definite curve. So I don't really think that a linear regression model is appropriate. So over here in my notes where it says, would you use a regression model? I would say a linear model is not appropriate. The original scatter plot shows a slight bend, but the residual plot shows a clear curved pattern. So let's get into, so what do we do in this scenario to bypass all of that? So since we expect that this data is nonlinear, we cannot make a linear regression. However, we can transform the data to make it more linear. And you might be thinking, well, in other courses, I've looked at quadratic models and cubic models and logarithmic models. Maybe they're a better fit, and they truly may be. But in statistics, we can learn so much by looking at a regression model. R squared, for instance, only works with a linear model. So for the purposes of stat, we have to try to linearize our data. So your textbook and the other video I've posted on Schoology go through a lot of different ways. On the AP exam, most likely you'll just have to interpret a model. But if you would be asked, I'm going to show you three ways to re-express your data. Really what I'm going to have you do is compare x versus the log of y. And I know this is a little weird because we're so used to, in math, whatever we do to like one side of an equation, we do to the other side. And here I'm telling you to only mess with one variable at a time. So I want you to then look at the log of x versus the log of y and see if it straightens it. And then if that doesn't work, then we'll transform both variables. So it's really important that you keep track of your lists as you do this. So I write it down just because probably I'm old and my memory is bad, but I'm going to go into my list and I'm going to hit edit, and I'm going to go over to L3, and I'm going to tell L3 to transform all of list 1 by doing the log of L1. So I go up to L3 and I'm going to take the log, and you could do the ln, I'm just partial to log, so I do log of list 1. And what that's going to do is it's going to take the log of every single data value in list 1 and store them now in list 3. Okay, so look at how much smaller these numbers are. Right away, I'm going to go over to L4, And actually, as I do this, what I like to do is, so I know that my original x is in L1, my original y is in L2. I'm going to store the log of x in L3, and I'm going to store the log of y in L4. I just always note that somewhere on my paper because at some point I know I get mixed up. All right, so go up to L4, and I'm going to immediately do the log of L2 for the log of my y's. Hit enter. And there you go. So what I'm going to do now is I'm going to run my regression for this transform data. So I'm going to get out of my lists, and you know what, I'm actually going to go up and rerun my previous regression because I forgot to write down what my R squared was. Okay, you could write down your entire model. For sake of time, I am just going to calculate. So on my original regression, R squared was 0.91, which is pretty good, but the issue was, you know, we saw that it had a bend. All right, so I'm now going to run my regression for x versus the log of y. So stat calc option 8 and L1 versus the log of y I said was stored in L4. So I changed this to L4, run my regression, calculate. The residuals now are automatically stored in the background of the calculator for this new list. My R squared here, I'm going to record it. Look, it got a little better. 0.96, that's pretty high, but I got to check. Did I fix my scatter plot? So I go to stat plot. I'm going to look at the original scatter plot. So in here, I changed this to L1 versus L4. See why it's important to track your lists. L4, zoom 9. Let's see if it's straightened at all compared to the original. Yeah, I'd say that's looking a little straighter here. Now let's actually look at the residuals. So they were stored in the background, and I'm going to do L1 versus the residuals. Option 7 again. There we go. Zoom 9. Ooh, that's looking a lot better. I'm seeing much more random scatter here. I'm liking this one, okay? But maybe I can do even better. I can create an even better model. So let's now compare the log of x versus the log of y. So I'm going to again run my regression model, so stat calc option 8. And as I do this, I kept track of my lists. So I'm doing the log of x this time versus my original y. So that was list 3 versus list 2. Okay, list 3 versus list 2. Run my regression. I'm going to write down my R squared right away so I don't lose it. R squared here, got a little worse, 0.85. So it's probably not real great for just to look at my original scatter plot. Let's check it out. So L1, nope, I'm sorry, L3 versus L2, L3 versus L2. Zoom 9. I'm still seeing a curve here, okay? But I did tell you to sketch the residuals, so stat plot again. Is that not working? Okay, I think my video just jumped a second here, but here's my residual plot, and check this out. I see a major curve in my residual now. So I saw that my R squared got a little worse. It's measuring how good my model is, and check out that curve there. So definitely not liking the log of x versus y. So far the best one appears to be x versus log of y, but let's just check out our last one where we take the log of x versus the log of y. Perhaps that could make it even better. So as I look at this, let's see, so log of x versus log of y. So I'm going to be comparing L3 versus L4 in this one. So I'm going to stat calc, option 8, and I'm running L3 versus L4. Run my regression. Just move this over so you can see. 0.97, gosh, that's pretty good. And let's see, how did that compare to my other one? It's off the screen. Let's see, was that better or was that worse? Ooh, that's better, okay. But I gotta actually look, did it straighten things? Because I could have something deceiving happening here. So look at your original scatter plot. So I think you're picking up on, yeah, there's a lot of steps here with the calculator, so it's definitely something you want to practice so you, do it well, keep it straight in your brain. All right, so L3 versus L4, I do zoom 9. Okay, so it's looking pretty straight here. Yeah, I've got some scatter here, but I don't necessarily call that a bend. Let's look at my residual plot. So again, second stat plot, and my original x's are in L3. My residuals are stored in the background because I did remember to run my regression. Remember, if you don't run your regression, your residuals are not stored. There's option 7. So there I've changed it to my original x's, or the log of x's are in L3 versus the residuals of the last run. So zoom 9, and that's looking pretty good. I see mostly random scatter here. Sometimes people might argue that they might see a little bit of a pattern. I'm not thinking that that's too bad. So this one here seems to be my best fit. All right, so what do we have here? Let's go on to our next question. So, which model is best? Write your model. We liked the last one, which was the log of x versus the log of y. And that's not my model, though. All right, so I'm going to actually write out my regression equation using that. So in context, I'm going to put the log of my predicted y, which was units sold. So I put a hat over that, is equal to, and you might have to go back and run it again. I can probably just go up into my history and run it one more time here so I can see my different values. So the log of units sold is equal to negative 4.132 plus 4.48 times not years, but the log of years. Okay, so I've got the log in there twice this time. I'm going to just zoom out a little bit so you can see. And then it says, according to this model, how many iPhones were predicted to be sold in 2015? So 2015, looking back at your original data, is 15 years after, so we're just substituting. So I just plugged in 15 right here, did it on my graphing calculator and got approximately 1.137, but that's not the predicted units sold because we've transformed our data. We did the log of the predicted units sold, plus, they sold definitely more than 1.137 iPhones. That doesn't make sense. So I need to solve this equation by exponentiating. So I'm going to put a 10, make that my base, and now I have the predicted units sold would be 10 to the 1.137, which is approximately 13.7 million. So make sure you get the million from your original units on this actual example. Okay. The final example says, calculate and interpret the residual for the number of iPhones sold in 2015. So recall that a residual is equal to your actual minus your predicted. So we have our predicted from the previous, and if I go back to my original data, it was actually 30.